Hello everyone. And about the midterm exam, I will announce the results of midterm exam next week. And yesterday I update the results of assignment 2. And if the accuracy of your program is not 100, and you still have chance to update your program. And the deadline is today, 12 o'clock p.m. And for this assignment, because the input combinations are finite, so it is possible to print all the possible calendars. The range of the first input is between 21 and 31, while the range of the second input is between 1 and 7. So it is possible to print all the calendars. And you can print all the possible calendars to inspect your program outputs. And I also announced assignment 3. And later I will explain this assignment. And last time we learned the syntax of array, and we also how to combine the use of array and the functions. And the next we will learn some common operations about our array. Like searching and sorting. And the last part of this chapter is multi-dimensional array. And we have learned how to fill an array. And this example is in we have learned this example, fill use and function to fill an array, and this function is in page 15. And next, let's see another example. Another example is partially filled. We don't need to fill the entire array. We can partially fill the array. And you can find the program of this example in the course website. And you can click the reference, web page, and then you can find the chapter of array. And in this item, there are many source code. For example, you can download this one, test array partially filled, or test array search. And you can try to modify this source code to see what happened. And because this example is similar to fill up array, so I will skip this one. And if you are interested, you can download the source code to run this program. And next, let's see another common operations with array, which is searching. And searching means given an array and given one target, and we want to find whether the target is in the given array. If the target is in the given array, then we need to find the corresponding index. So this function search has some inputs. The first input is an array, and another input is the target. And target means the element we want to find in array. And there is also another input. You can think the number used is like the size of the array. And this function search will return an integer, and this integer is the index of the element we want to search. So here, array is the given input, and you see that there is one bracket. So this means this variable is an array, and each element is an integer. And we also have one keyword const before integer. And here const means we cannot modify array inside this function. So if we add this keyword, then this means we cannot modify array inside this function. If we try to modify the keyword, then the compiler will give error messages. And because we just want to search, so we don't need to modify an array. So here we add the keyword const. And in the definition of search, first we declare one variable index, and this variable is the index of the element we want to search. And we also declare another Boolean variable found. If we can find target in the given array, then found is set to true. Otherwise, found is set to false. And we set the initial value of found to be false. And later, next we use a for loop to iterate the array. And we initialize the index to be 0. And in each iteration, the index is increased by 1. And until index is less than or equal to number used. And inside the for loop, we use one if statement to check whether the target is equal to array index. And if this comparison is true, then this means target is in array, and the index is the index is what we want to find. So if this comparison is true, then we set the Boolean variable found to be true, and then we break this for loop, because we already found the target. And if this comparison is not true, then the for loop will continue. And if the target is not in the array, then this if target is not in the array, and then this for loop terminates, and the found will be still, and the found will not be modified. So found will be false. So if target is not in the array, then found will be false. And next we will go to this if-else statement. If found is false, then we will go to the else part. So this function will return -1, because the index is always non-negative, and we use -1 to means the target is not in the array. And if we have found the target, then we return the index, and index is the position whether the input target in the array. And you can write a simple program to test this function. For example, we can use the online IDE. And for example, I declare an array, and this array has 5 elements. And suppose my target is 3. I want to check whether target is inside this array. So I call the search function. I call this search function. And let's see the program output. And I print the return value of search, and the return value is the index. You can see the definition of this function, the return value is index. If target is found, then the return value is index. And for this example, 3, the target is 3, and this target is in this array, and its corresponding index is 4, because it is at the last element, and the size of the array is 5. So the index of 3 is 4, and you see that the search returns the index of the target, which is 4. And you can change the target. For example, you can change target to 1. And the return value of search should be 4, because 1 is the fourth element of the array. So we see that the return value of the search function is 3, because 1 is the fourth element of the array. And you can also change target to another value. For example, I change target to 4. And for this target, it is not in the array. So search should return -1. And we see that the return value of search is -1, because target is not in the array. And search is one common operation with array. And this example introduces how we can implement the search function. And for this example, we are not allowed to modify the array function inside search, because we add a const keyword. If we try to modify the array, for example, I try to modify the array inside search, then the compiler will give error message, because the assignment of array is read-only. But because the array is read-only, so we cannot assign values to this array. Because if we add the const keyword, then the array becomes read-only. And this means we cannot modify array inside the function. But if you remove the const keyword, then you are able to compile this program. And for this example, for this if statement, you can also write if found is not equal to false. You can also write in this way, but this is redundant, because if found is already false, then you don't need to compare it with false. So you can just use this way to check whether found is false. And let's see another common operation with array, which is sort. Many applications requires us to sort an array. And for sorting, there are many ways to implement sorting. And one of the simplest sorting method is bubble sort. But this type of sort is not very efficient for large arrays. For example, if your array consists of 1,000 elements, then it will be inefficient to use bubble sort to sort the array. Bubble sort is used for array of small size. And another implementation of sort is quick sort. And this method is more efficient than bubble sort for sorting large arrays. So if your array is very large, then you can using quick sort is more time efficient than bubble sort. And I will not go into the details of bubble sort and quick sort, and because the details, if you are interested in the details, you can go to the reference web page, and I list some references for bubble sort and quick sort. And I also give some example program. You can download this program to run the bubble sort or to run the quick sort. And the reference has some illustrations how bubble sort or quick sort, how the two algorithm works. I will not go into the details of bubble sort and quick sort, but I will show how we can perform sort in C++. And in C++, we have a standard library algorithm. And inside this library, there is one function called sort. And we can use this function to sort an array. For example, I copy the example in the slides, and I add a for loop to print the value of the array. And to use sort, we need to include the library, and here so after I declare the array, then I use a for loop to print the values of this array. So the printed values are 4, 1, 9, 8, 5, 2. Then I call the sort function. I call this function to sort the array. And to use this function, we need to give two inputs. And the first input is the array's name. The first input is the array's name. And the second input is array's name plus array size. And in this example, array size is 6. And in the later chapter, we will explain this syntax. In fact, array is a pointer, and array plus array size is also another pointer. Pointer means the address, means memory address to some variable. And later we will in next chapter we will learn what is a pointer. And here the first element, the first input of sort is array's name or a pointer, and the second input of sort is also another pointer, and this pointer is array plus array size. And after this function call, I use the for loop to print the values of the array. And we see that after sort, the array is already sorted. This array is sorted in ascending order, so the values of each element is increased. And for this example, I use the size of to compute the array size. So you can change 6 to array size. And a better way to write this program is to define functions. For example, we can define a function to print the values of the array. A better way is to define a function, display array. Then I define this function to print the values of array. And you can see that the structure of this program is more clear because the function name, from the function name we know that this line, the purpose of this line is to display array. And you can reuse the function, so you need to copy and paste the same code. So to write, use function is a better programming skill because this skill can make your program more clean. Your program will be more readable. And this program is also very flexible because if you change the size of the array, you don't need to change you don't need to change the implementations of this function. So this program is also very flexible because if you change the definition of array, you don't need to change other parts of this program. But if you, for example, if you fix this value, if you fix this value to 6, then this function can only display an array with 6 elements. So if you want your function to be more flexible, then you should use variables. So if I want my function to be able to deal with any array size, so here I should use the array size variable. So if we want to sort an array, we can call the sort function in the algorithm library. And in fact, in this algorithm library, there are many other methods. For example, you can search the algorithm library. And there are other sorting methods like stable sort, partial sort, and also other algorithms like binary search or merge or heap. So if you can check whether your applications needs which method, and then you can search this library to see if there is some function you can use in your application. And next, we will go to the last part of this chapter. And this slide is about multi-dimensional array. And previously, we assumed that the array is one-dimensional. But in C++ or C language, the arrays can be multi-dimensional. And in this example, we can create a two-dimensional array. And usually, a two-dimensional array is called a matrix. So for this statement, we declare an array page. And this variable is two-dimensional because after the variable name, there are two brackets. And inside the first bracket is the size of the first dimension. And inside the second bracket, 100. 100 is the size of the second dimension. So this line creates a two-dimensional array. And the size of the first dimension is 30, while the size of the second dimension is 100. And we can use bracket to access the element of this array. This is just like the one-dimensional array. And I list all the legal index in this slide. For the first index, its legal range is from 0 to 29 because the size is 30. Because the size of the first dimension is 30, so the legal range is from 0 to 29. And for the second dimension, the legal range is from 0 to 99 because the size of the second dimension is 100. And in fact, C++ allows any number of indices. For example, you can create a three-dimensional array, or you can create a four-dimensional array. So you just add more brackets. This is one example of how to declare a two-dimensional array. And here I use named constants. I define two constants, max students and number quizzes. And gray is a two-dimensional array. And this, you can think a two-dimensional array as a matrix. And this matrix has 4 rows and 3 columns. And the first row is 2, 10, 8. And each row has 3 numbers. So each row corresponding to 1 student. And each number and each column corresponding to a quiz. And for this example, gray is a matrix of 4 rows and 3 columns. So we can visualize this two-dimensional array. And if we want to access the grades of student 1, then we can use grade 0 to access the quiz 1 of student 1. So the first index determines which student we want to access. So if we want to access the grades of the first student, then the index at the first dimension is 0. And if we want to access the grades of the second student 2, then we can let the index at the first dimension be 1. And the second index controls which quiz we want to access. If we want to access the first quiz, if we want to access quiz 1, then the second index is 0. If we want to access quiz 2, then the second index is 1. And again, you can copy this example to the IDE, and you can copy this example to IDE. And then we can print the values of this two-dimensional array. And in next page, there is one example. We can use this function to display the elements of the two-dimensional array. So here I copy this function. And this function has a nested for loop, and the first for loop controls the first dimension, and while the second for loop controls the second dimension. And the first dimension is about which student. And while the second dimension is about which quiz. And the first dimension use the index S, while the second dimension use the index Q. And we can use grade SQ to access the element of the two-dimensional array. And the second input of this function is the number of students we want to display. Suppose I want to display the quiz grades of 4 students. And in the main function, first I declare a two-dimensional array, and then I call the display original grades, and this function will display the values of the two-dimensional array. And the program output is like this. The first row is 2, 10, 8. This is the same as the initialization. And we can control how many students we want to display. For example, if I only want to display the grades of the first 2 students, and then I can change the second input of the function. And in the definition of the display original grades, I also call another function called setW. And this function means set width. I set the output width to be 5. And this is for alignment. Because I want the output to be aligned, so I call this function setW. And this function is in the I/O manipulation library. So if we want to use setW, then you need to include I/O manipulation library. And you can change this number to other numbers. For example, I change from 5 to 7. And you notice that the output space is larger because each column will be 7 characters. But if you change the number to 3, and you will notice that the space is the space of each column is changed to 3. So we can use setW to align the outputs. And let's take a break for 10 minutes. Hello everyone, and let's continue our class. And we have learned how to use two-dimensional array. And this chapter is finished. And we will go to the next chapter. And before introducing the next chapter, I will explain the assignment 3. And the due date is 3 weeks later. And about this assignment, this assignment is about decoder. And let's see what is a decoder. And this program is to convert a sequence of bits into messages. For example, suppose the input bits are zeros and ones, like this sequence. And our goal is to convert the input sequence to meaningful information. And in this example, the meaningful information are English letters. And here, 1 corresponding to A, and 1 0 corresponding to B, and 0 1 corresponding to C. And this process is known as decoding. To convert the sequence of bits into messages is known as decoding. And the reverse process is known as encoding. For example, given English letters, we want to encode in a sequence of bits. And the reverse process is called encoding. And this assignment is about decoding. So the input is a sequence of bits. And for this example, suppose the input bits are 0 1 1 0 0 0 0 1 1 0, and so on. And the decoding process is from left to right. So we need to start from left. So we start from 0. And then we check this table. If the bits begins from 0, it can be C or D or E. So there are 3 possibilities. And then we need to move to next position. We move to 1. And so now we have 0 1. And you check this table, you find 0 1 corresponds to C. So at this time we can output C, because we know 0 1 corresponds to C. And after we output C, then we moved to the next position. The next position is 1. And we check this table. If the position begins with 1, then there are 2 possibilities. It can be either A or B. So we need to move to the next position. And the next position is 0. And the 1 0 corresponds to B. So at this time, we can output we can output a B. And then we moved to another, to the next position. The next position is 0. And again, you check this table. If the position begins with 0, and there are 3 possibilities, C, D, and E, and we need to move to the next position. The next position is 0. So 0, 0 corresponds to either D or E. And we need to move to the next position. And the next position is 0. So now we have 0, 0, 0. And at this time, we're sure that we should output E. So because 0, 0 corresponds to E. So at this position, we should output E. And you can continue this process to decode the input bits. And I also provide, so in this example, the program input is the sequence of bits. And the program output is English letters. And I also give a code template. And I declare a string code. And code is an array of characters. So code is an array. And I declare an index I. And I use a while loop to iterate, to access the element of the array code. And you don't need to worry about the input length. The input length is given by code.length. So you don't need to worry about the length of the input. You can access the length of the input with this function code. For example, if you want to check whether the character at the index I is 0, is character 0, then you can use this if statement to check. So you add your code inside the while loop. So for this assignment, you should enter your code inside the while loop. And do not change the first line, the first CL and the last CL. Do not change the 2 lines. And you only need to output characters A, B, C, D, E. And you don't need to output line breaks and the other characters. So inside the while loop, you only need to print A, B, C, D, E. And I also give more input-output samples, and you can, after you finish your program, you can test your program with more input-output samples. For each input, the answer is unique. So given the sequence of bits, the output will be unique. And you can assume that the input sequence is legal. because there are other scenarios, the input sequence might not be legal. But for this assignment, you can assume all the input sequence are legal. And for this assignment, you need to ensure the array index is within the legal range. For example, if you use code I, and here index is I, then you need to ensure I is greater or equal to 0, and I is less than or equal to code.length -1. Or if you use code I plus 1, and for this example, the index is I plus 1, and you need to ensure the index I plus 1 is within the legal range. That is, I plus 1 is greater than or equal to 0, and I plus 1 is less than or equal to code.length -1. And if the array index is not within the legal range, and then your program will cause runtime error. And if any runtime error occurs, then the accuracy of your program is 0. So you need to make sure that the array index inside your program is always within the legal range. Otherwise, the accuracy of your program will be 0. And this assignment is for you to practice the use of an array. And if you are interested in the story behind this assignment, you can refer to this link for the motivation of encoding. For example, you can think the reason why we need to use this encoding. Why we not consider other types of encoding. And for assignment 3, the due date is 3 weeks later. And if you want to send your assignment, remember the rules. You can use this link. You can use this link to send assignment 3. If you do not follow this rule, then your assignment will not be processed. And next, let's return to our slides, and we will go to the chapter about parameters and overloading. And this chapter has 3 parts. And the first part is about function parameters. And we will learn what is call by value and what is call by reference. And the second part is about overloading of function. And the third part is about how we can test and debug functions. And there are two types. There are two methods of passing arguments. The first method is called by value, and the second method is called by reference. And what we learned so far is all called by value. What we learned so far is all called by value. And I will use an example to illustrate what is called by value. And you can copy this example into the IDE. And for this example, I define a function phi. And this function has two inputs. The first input is hours worked, and the second input is minutes worked. And this function will return the value of phi based on the two inputs. And inside the main function, I call the function phi with two inputs, hours and minutes. And the initial value of hours is 12. And while the initial value of minutes is 30. And let's see after this function call, what is the value of hours and minutes. So after this function call, I will print the values of hours and minutes. After this function call, I print the values of hours and minutes. And we know that the values of hours and minutes are not changed after this function call. When we call this function, when we call function phi, the value of hours will be copied to this local variable, hours worked. And the local variable, hours worked, is changed. Sorry. The local, we initialize the variable minutes to be 30. Then 30 will be copied. Will copy to the local variable minutes worked. And then the local variable minutes worked is changed in the first line of the function definition. So the values of the local variable minutes worked is changed, but we know that the value of minutes is not changed, because the values of minutes is still 30 after the function call, and this is known as call by value, because we copy the value of minutes to the local variable minutes worked, and inside this function only the values of the local variable minutes worked is changed. So this change will not affect minutes in the main function, because this line only modifies the local variable and will not affect the minutes variable in the main function. So the values of minutes is not changed by the call to phi, because minutes worked is a local variable, and inside the function we only change the local variable. And this mechanism is known as call by value. This mechanism copy the actual argument to the local variable inside function, and if the local variable is modified, then only local copies are changed. And this is the default method, and is what we learned so far. And next, let's see another method. This method is called call by reference. And we will use one example to illustrate what is call by reference. I will use this example to illustrate call by reference. So let's modify this example. For example, if I want to change the value of minutes inside the phi function, then we can add the AND operator after the data type. You can add a space or no space. They are the same. If I add the AND operator after the data type, then this function call will become call by reference. And let's see the program output. And you pay attention to the value of minutes. And we see that the values of minutes changed. In the previous example, the value of minutes is 30, but if I add one AND operator in this example, then the output of minutes changed, because the mechanism is changed. if I add one AND operator, then for this example, the value of minutes worked is hours worked times 30 plus minutes worked. So hours worked is 12 because I input 12. So 12 times 60 is 720, and the plus minutes worked plus 30. So here minutes worked becomes 750. And if I add the AND operator, then this value is the same as minutes, will be the same as minutes. So after this function call, the value of minutes will be the same as minutes worked. So after this function call, the value of minutes is 750. This is because we not copy the value of minutes. Because if we add the AND operator, then the memory location of minutes will be sent to minutes worked, and any change of minutes worked will affect minutes in the main function. And this mechanism is known as call by reference. So it makes difference whether you add the AND operator. So if you don't add the AND operator, then the value of minutes will not be changed inside after the function call. But if you add the AND operator, the value of minutes will be affected after the function call. And I will use another example to illustrate call by reference. For this example, I want to define a function, and this function has two inputs, variable 1 and variable 2. And the purpose of this function is to swap the values of the two inputs. So if the input value is A and B, then after this function call, I want to swap the values of A and B. So after this function call, the values of A and B are changed. And for this example, the initial value of A is 1, and the initial value of B is 2. Then after this function call, swap values, I print the values of an A and B, and the value of A becomes 2, while the value of B becomes 1. So after this function, swap values, the values of A and B are swapped. And this function will use the call by reference mechanism. And let's see how we can define this function. This function has two inputs, variable 1 and variable 2. And the two variables are integers. And after the data type, I add the AND operator. So you can either add a space or no space, it's okay. So you can and then inside the function definition, I declare a temp variable. And the temp variable is to save the value of variable 1. And then I assign variable 2 to variable 1. So the values of variable, after this line, the value of variable 1 will be the value of variable 2. Then I assign temp to variable 2. And after this line, the value of variable 2 will be the value of variable 1. So this is the function definition of swap values. And because we add AND operators, so the function call, so if we change the values of variable 1 and variable 2 inside this function, and this change will affect the caller data AB in the main function. So we see that after the function call, swap values, the values of A and B are changed. But if you remove the AND operator, we see that the function call will not change the value of A and B. Because if you remove the AND operator, then the mechanism is call by value, and any change of the local variable will not affect A, B in the main function. So if we want to change the values of A, B after this function call, we need to use call by reference. So we need to add the AND operator. And the next example define more function. And you can copy the functions to in the next style, I define more function. For example, I define a getNumber function, and the getNumbers function is to read inputs from the user from the standard input. Then the inputs from the user will be saved in variable 1 and variable 2. And we know that I add two AND operator in the function definition, because if we don't add the AND operator, then this function will be call by value, and the call by value will not affect variables in the main function. Let's see how to use this function getNumbers. And initially, the value of A is 1, and the value of B is 2. Then I call getNumbers, and the getNumbers will use cin to read two numbers. So here, I will enter two numbers. For example, I enter 4 and the 5. And the 4 will be saved in A, and the 5 will be saved in B. So after this function call, the value of A will be 4, and the value of B will be 5. So after the function call getNumbers, the values of A and B are changed. So here we need to use call by reference. We need to use call by reference. So we need to add AND operators. If you remove the AND operator, the program is still legal. For example, I input 4 and 5. But after getNumbers, the value of A and B are not changed, because I remove the AND operators, and this becomes call by value, and the call by value will not affect A and B in the main function. So if we want to read user inputs in the function, so we need to use call by reference. And we can use getNumbers to read inputs from users, and we can call swap values to swap the values of first number and second number. And we can call show results to print the values of first number and second number. And you see that for the show results function, we don't need to include the AND operator, because for show results, we don't need to modify, we don't need to use call by reference. So for show results, we don't need to use the AND operators, because show results only print the values of the two inputs. And for show results, we only use call by value. But for the previous two functions, for get numbers, we need to use call by reference, because we want to read user inputs in this function. And for swap values, we want to swap the inputs, the two inputs. And this mechanism is known as call by reference. And what is really passed in the function inputs? And it is actually the memory location or memory address is passed to the function. And this slide is about parameters and arguments. And the two terms can be used interchangeably. You can skip this slide. It's not very important. And the next slide is about the mixed use of call by value and call by reference. So in the definition of a function, we can mix call by value and call by reference. For this example, the first input is call by value, and the second and the third inputs are call by reference. And let's see the definition of this example. In the main function, I declare three variables. Power 1 is 2, and the power 2 is 0. Power 3 is also 0. And after this function call, the values of power 2 and power 3 are changed, because this function is use call by value and call by reference. And this function modifies the value of power 2. The value of power 2 is 2 times power 1. So the value of power 2 is 2 times 2. And because the AND operator, so this is call by reference. And if we modify the value of power 2 in the function, this will affect power 2 in the main function. So after this function call, the value of power 2 is 4. And the value of power 3 is 3 times power 1. So the value of power 3 is 6. And because we use the call by reference for power 3. And you can create an example to test call by reference and call by value. For example, the initial value of PR1, PR2, PR3 is 200. Then after the mixed call, the values of PR1, PR2, PR3 are 2, 4, 6. The value of PR1 is not changed because because PR1 is called by value. So after this function call, the value of PR1 is still 2. But the values of PR2 and PR3 are changed. The values of PR2 and PR3 are 4 and 6 because PR2 and PR3 are called by reference. And if you change PR1 to call by reference, then the value of PR1 will be changed to 10 after the function call. For example, if I add the AND operator, then the value of PR1 is changed to 10. But if I remove the AND operator, then the value of PR1 is 2, which is its initial value in the main function. And let's take a break for 10 minutes. Hello everyone, and let's continue our class. About assignment 3, if you want to see the accuracy of assignment 3 in November 29th, then you should send your program before November 28th, 9 p.m. If you send your assignment 3 after November 28th, 9 p.m., then you need to wait until December 6th to see the accuracy of your program. So if you want to see the accuracy of your program in November 29, then you need to send your program before November 28, 9 p.m. And the rules for other assignment is the same. And we have finished the first part of this chapter. And next we will go to the second part, overloading and default arguments. And before introducing the second part, and this slide stresses the importance of choosing function names with meaningful names. For example, if we want to define a function to read student grades, then you can choose the function name to be read student grades, and this function name is meaningful, and it gives the reader the information of your function. And for another example, if you want to define a function to display student grades, then you can choose the function name to be display student grades. And you see that the two function names are consistent. The first word is a verb, and the second and the third word are student grades. The two function names are consistent, and this is a good function name. And good or meaningful function names can increase the readability of your program. Next, I will introduce overloading. And overloading means the same function name. We can define functions with the same names, but the input parameters can be different. If the parameter lists are different, then even though the two function names are the same, they are considered as two separate function definitions. And for a function signature. A function signature consists of two parts. The first part is the function name, and the second part is the parameter list or the input parameters. And the two part are called function signature. If any of the two parts is changed, then the signature is considered different. So even though the function name are the same, but if the parameter list is different, then the function signature is considered different. And when we will use overloading, we will use overloading for functions to perform the same task on different data. And the next, I will give an example. For this example, it defines a function average. The first function is has two inputs, while the second function has three inputs. And the function names are the same. The function names are average, but the parameter lists are different. The first parameter list has two inputs, while the second parameter list has three inputs. So the function signature of the two functions are different, although they have the same function name. And for this example, why we choose the same function name? Because the two functions perform the same task. The two functions all perform the average task. The task to average the input numbers. So because the two functions perform the same task, so we choose the same function name. And this is known as overloading. And the two functions are considered different, are considered two separate function definitions because the function signature are different. And this example is not a good example for demonstrating overloading. Sorry, And this example is not a good example about overloading, because this example can only work for two inputs or for three inputs. But if our inputs, if the number of inputs is more than 3, then this function cannot be applied. So it is better to write a function that can deal with arbitrary inputs, and you can think how to write a function to deal with arbitrary inputs. And we already learned how to do this. How can we define a function to deal with arbitrary lengths of inputs? If we can do that, then we don't need to define many functions. We only need to define a single function. You can use array. For example, you can let the first input to be an array, and let the second input be the array size. Then you can write a for loop to compute the average of the array. And then in this way, you only need to define one function. And this function is more flexible than the two functions in this slide. And this one common pitfall for about overloading is to abuse the use of overloading. For this example, the first average computes the average of two inputs, while the second average computes the multiplication of the two inputs. And the two functions use the same name, but the parameter lists are different. The first parameter is use double data type, while the second parameter list use integer data type. So the function signature are different. So the two are two separate function definitions. But the two functions use the same name. So this is overloading. But this usage is misleading, because the first average performs the task of averaging, while the second function does not perform average. So the second average is misleading, and we should not abuse the use of overloading. And overloading should always perform the same task in all overloads. Because if you do not, because if the overloading does not perform the same task, the readers, the users of your the users of the function will be confused. And next, this is about some details about the overloading function. And we can use examples to illustrate the details of function overloading. And in this example, I define a function mpg, and this function has two inputs, and the first input is a double, and the second input is also a double. And now suppose I make a function call in the main function. Then the compiler will find this function definition. Because the input 5.8 is a double, and the second input 20.2 is also a double. But let's consider another function call. Suppose the first input is 5, and the 5 is an integer. And so the compiler will not consider this function first, because the data type is not exact. The first input is integer, while the first input of mpg is double. So this function definition is not exact. Does not match exactly with this function call. But if there is no other appropriate function definitions, then the compiler will try to convert 5 to 5.0. And then this function call will match this function definition. So if we convert 5 to 5.0, then the first argument, then the first input will be a double. And this function call will match the function definition. And similarly, if the function call is mpg 520, the first input is an integer, and the second input is also an integer. And this function call does not match the function definition exactly, because the input data types are different. But if there are no other function definitions, then the compiler will try to convert 5 and the 20 to doubles. And after the conversion, the function call will match the function definition. So the details about the overloading, the compilers will first try to find exact match of the function call. To find the exact signature, and if exact match is found, then no argument conversion is required. But if the compiler cannot find, but given a function call, if the compiler cannot find exact match, the compiler will try to find compatible match. And this time, the compiler will try to perform type conversion. For example, it will try to convert integer to double. Or if this is failed, it will try to convert double to integer. But if you convert integer to double, this will incur no loss of data. But if you convert double to integer, this might lead to loss of data. Because if you convert 2.5 to integer, then you lose 0.5. Next, below is another example about overloading. And consider three function declarations. The three functions have the same name, FUNC, but the parameter lists are different. The first parameter list is integer and double, while the second parameter list is double and integer. And the third parameter list is integer and integer. So although the function name are the same, but the parameter lists are different. And if we make function call, for example, if we make this function call, FUNC 98, 99, and both inputs are integers, so the compiler will try to find exact match, and the third declaration is the exact match. So compiler will cause the third implementation. And the second function call, FUNC 5.34. The first input is a double, and the second input is an integer. So the second function definition, the second function declaration is also the exact match. And next, let's consider the third function call. And the two inputs are doubles. But this time, we cannot find exact match, because the three function definitions do not correspond to double. So for this function call, we cannot find exact match. And the compiler will try to find the compatible match. But this time, all the three function declarations can match this function call after the compatible match, because the three function declarations all compatible with the third function call. So the third function call will cause confusion. The compiler or the reader cannot determine which function declaration will be called. And therefore, we should avoid the use of such function call. We should avoid such confusing overloading, because for this overloading, we do not know which function declaration will be called. Next is about one advanced C++ syntax And this syntax is called function templates. And this feature allows you to parameterize the data type. Previously, we assumed the data type is fixed, because if you define a function or you declare a function, the data type is fixed. But in some applications, you might need to parameterize your data type. You want your data type to be adapted to your use. So your data type might be character or integer or double. And for this application, you can use function templates. And this feature is an advanced feature in C++. And if you are interested about this feature, you can check the textbook. The textbook has one chapter about function templates. And I will not go into the details because the time is limited, so I cannot introduce every details. And next, let's see another feature about function. This feature is called default arguments. Default arguments is to give default values to the function inputs. And the benefit is that the users can omit some arguments. And let's see this example. For this example, I define a function show volume, and this function has 3 inputs: length, width, and height. And this function will print the volume. The volume is the multiplication of length, width, and height. And I can call this function like this one. I give 3 inputs, 2, 4, 6. So for this function call, the console outputs 48, because 2 times 4 times 6 is 48. And if we want to give default values to the inputs, for example, I want to give default values to width. Suppose the default value of width is 1, and the default width of the default value of height is 1. Then we can use this syntax to give default values to the input parameters. And for the second function call, I only give 2 inputs. So the value of length is 3. The value of width is 5. But I did not give the value of height. And therefore the value of height will be set to 1. So for the second function call, the output will be 15, which is 3 times 5 times 1, because the default you mean that this one? You cannot do this because the second input is empty. So this is syntax error. Will cause syntax error. You cannot give empty input. So because C++ does not allow empty input, so this die will cause a syntax error. And if you want to do this, you need to change the order of width and height. If we want to do assign height first, you can change the order of height and the width. And for the third function call, I give only one input. So 7 is assigned to length. And I did not give values to width and height. So width will be set to 1, and height will be also set to 1. And CR will print 7 times 1 times 1. So the output is 7. And we know that the order is important. The order, the function call will follow the order in the function declaration. So the first input is length, the second input is width, the third input is height. Your function call will follow the order in the function declaration. And you can also give initial value to the first element. Then you can call a show volume without any input. And this time show volume will output 1 because the default values of the 3 inputs are 1s. So if we want to give default values to input parameters, we should change we should give initial values to the input parameters in function declaration. We do not give initial values in the function definition. If you need to give default values, you need to give default values in function declaration, or not in function definition. You can try to for example, if you try to give default values in function definition, this is not legal syntax because the compiler will assume the input the number of inputs is 3. So if you want to perform if you want to give default values to your input parameters, you should do this in function declaration, but not in function definition. And we have finished the second part of this chapter. So and now we will go to the third part, which is about how to test and debug functions. Just like you do your assignments, after you finish your assignment, you need to test your program to see whether your program works properly. And this part will introduce some techniques to debug your program. This slide lists 4 methods to debug your program. The first method is to use cout to print the values of variables. This is the most basic method to debug. And the second method is to use a debugger. Some IDE will have a debugger for you to trace the values of variables. And for this IDE, online IDE, it also has a debugger, or F8. You can try to, if you are interested, you can learn how to use this debugger. And the third method is to use the assert macro to check the values of your to ensure the values of variables are inside the inside a given range. This is the third method. And the fourth and the last method is to use stubs and drivers to perform incremental development. And later we will see how to use the fourth method. And the third method is to use the assert macro to check whether the values of a variable is inside the reasonable range. For example, suppose we declare a function compute coin, and for this function has 2 inputs. The first input should be between 0 and 100. While the second input should be between is also between 0 and 100. And if the 2 inputs are not inside the given interval, then we should not perform compute coin. And you can use if statement and logical operators to check the value of coin value and to check amount left. You can use if statements to check the values of the two variables. And you have other option. You can use assert. For example, if I want to ensure coin value is greater than 0, and I want to ensure coin value is less than 100, then I can call the assert macro, like this one. For example, I declare a variable coin value, and its initial value is 50, and I can use assert to check its value, whether its value is inside the reasonable range. And if this value is outside the reasonable range, then the compiler will gives error message. For example, the value of coin value is 120. It's outside. It's not less than 100. So the compiler will give error message in the 10th line, and this line says assertion failed because 120 is not less than 100. So we can use assert to check the value of a variable. And you can also split this assert into two asserts. So you can also split this line into two asserts. And for this example, the compiler gives error messages in 11th line, in this line, because coin value is not less than 100. But if you change the coin value to -1, then the compiler gives error message in the 10th line, because -1 is not greater than 0, and therefore the assertion is failed. But if the value is between the reasonable range, then the compiler will not give any error message. And to use assert, we need to include this library, cassert. This library is already in the C programming language. In C programming language, this assert is in assert.h, and in C++ programming language, assert is in cassert library. And you can use some preprocessors to turn off or turn on all the assert, because in your program there might be a lot of assert. Then you can use this line. This line is known as preprocessor. If you use this line, Undebug, this means no debug. No debug will turn off all the asserts. So this line is for your convenience to turn off all the assert. And the time is up, so let's end here.